We are given a one indexed array of integers called numbers that is already sorted in non-decreasing order. They want us to find two numbers such as they add up to the specific target number. And the two numbers must be, um, I guess, in the numbers array, right? And yeah, I don't know. This is just a lot of explaining what an array is, right? So they have to be the numbers are that they want us to return are the indices of the two numbers which sum the target. And then they want us to like increment the indices by one for no reason, but we can do that. And then the tests are generated so there's exactly one solution. So we can have that guarantee that there will only be one unique answer, and then um, additional constraint they give us is we can't use extra space. Um, so for this problem, without using extra space, we can just solve it with two pointers. So let's say we have a array of some numbers. So say this is like our array, and then maybe the target, let's add like one more number actually. Okay, and then say they want us to find the target. We'll just say the target is like the sum of these two. So, or we'll say the sum of these two, 18. Okay, so we're going to have a left pointer, which will be at the 0 index, and then a right pointer, which will be at the last index. And then let me just do the indices. So like, okay, so those are the array the array indices. These are the array elements. Basically, we're gonna have a for loop, and we're gonna basically do two things. The first is we're going to see if we found the target. So we can check if we found the target by basically just summing the right pointer and the left pointer. And then, so that's the first thing. And then the second thing we'll do is we want to basically move the right pointer and the left pointer, but we need to have a strategy to basically know when to do that. So the condition for the strategy will basically be the size of whatever the sum is. So like in this case, the sum is 2 plus 14 is going to be 16. So we compare that with the target. And then that's how we know what we want to do with the pointers. Because remember, our input array is sorted, which this actually isn't sorted. So let me fix that. But our input array is guaranteed to be sorted. So we're going to take the 16. What that allows us to do is when we move our right pointer, this sum is going to get smaller, right? Because what happens when you move the index of a variable that's tracking something in this array, like say we move this, what happens when we move this pointer to the left? Well, it's going to go to a smaller number, right? Because the array is sorted. So that's going to shrink the sum. So if our sum is too small, we want to grow it, right? So in the opposite case, we want to move our left pointer, right? So for this first iteration of the loop, we're basically, we can see these two guys are less than the target. So we're going to move the left pointer. Okay. And then we'll check again. Okay. 7 plus 14. Does that equal the target? No, it does not. It's 21. So 21 is now greater than the target. So we actually want to shrink this sum. So for this iteration, we're going to move the right pointer down to the left. Okay, so then we're going to check again. Are we at the target? Yes. Once we're at the target, we can just return these indices, so 1 and 3, but they want us to return it as a 1-indexed array, so the answer would just be 2 and 4. So for our time and space, our time is just going to be big O of n, because we're guaranteed to have the solution somewhere in this array. I mean, imagine it's like a huge array, and then the the targets could be, or the answer could be somewhere like on one side. Like basically it's going to tend to, it's going to be linearly bounded. And then the space is constant because we just have 2 pointers to keep track of. So constants O of 1 space. Yeah. All right. Let's code that. So we need a left pointer, which will be 0, and then a right pointer, which will be at the end of our numbers array. So we'll just say numbers.size -1. And then we're going to say while our left pointer, or while our right pointer is greater than our left pointer. So like while they aren't overlapping, we're going to first check, right? So leave a comment, check, right? The first step. So we're going to basically check to see if we found our answer. So if numbers at right plus numbers at left, if that's equal to the target, then we can just return that as the answer, right? It would be, and I think they want it in order for this one. 2 numbers be, okay, yeah. So this was something kind of important, right? This specifies basically that the answer should be returned in the order which they're found. So like ascending order. So we'll just say L plus 1, R plus 1. And then otherwise we've got to move the pointers, right? So we want to check, right, like what the size of this sum is in relation to the target, right? So and there's only 2 cases, right? So we just can think of one, and then the other one should be automatic, right? So if this sum is greater than the target, what do we want to do? We want to shrink it. So we have to move the right pointer backwards, right, or downwards. So we can do right minus minus. And then the only other case is going to be that the target is, or this sum is less than the target, right? We want to grow the sum. So then we increment our left pointer. We move it upwards. So that's pretty much it. They do say there will always be a solution, but kind of like in C++, your method is supposed to always return something. So we will just return -1 at the end. It shouldn't matter with their test cases. So yeah, that's it for this. Hopefully that helps, and I'll see you guys. Peace.